We'll show you how accurate you were a bit later, but most people find it challenging to identify these celebrities from their photo fits. Even if they can identify them, most would agree that the likenesses are pretty poor. Many psychological studies confirm this. For example, in one 2005 study using the latest feature-based photo fit software available at the time under forensically realistic conditions, people were able to name facial composites of celebrities between 0% and 3.2% of the time, depending on the specific software package used. Why is this? Can psychology tell us why photo fits are so poor at producing recognizable likenesses? Psychologists have been researching face recognition for a long time. One of the key early findings was a phenomenon known as the inverted face effect. This was investigated in an experiment by Robert Yin of the Massachusetts Institute of Technology. He showed participants a series of pictures of faces, as well as other types of objects such as houses and aeroplanes. Then he gave everyone a recognition memory test on the items, where he showed them pairs of pictures, in which one had been previously shown and one was new. Participants had to choose which of the pictures they'd seen previously. Crucially, some of these picture pairs were presented upside down. And here's the results. On the vertical axis, we have the number of identification errors they made. What Robert Yin found was that people had proportionally greater difficulty recognizing upside down faces as compared with other types of objects. So most people find famous faces proportionally harder to recognize upside down, but easy to recognize the right way up. Yin interpreted this as indicating that the mechanisms we use for face recognition are inherently different from those we use for processing other classes of objects. He suggested that in our brains, there is a processor that specializes in dealing with human faces. This idea has since been supported by lots of different evidence, such as patterns of brain damage, neuroimaging studies, and behavioral experiments. It's been argued that the reason that faces have their own special recognition mechanism is because they're a class of stimuli that we've been exposed to every day of our lives. And we have become super experts in telling apart faces. That is, our brains have developed a specialist recognition system for faces because, as social animals, we have to be specialists at recognizing faces, at telling people apart. So, why does being super experts in recognizing faces mean that they're proportionally harder to detect upside down relative to other objects? Martha Farrer of the University of Pennsylvania proposed that we recognize objects via two different mechanisms. These two mechanisms are housed in anatomically different areas of the brain. The first one uses a feature-based strategy. This involves decomposing objects into their component features or parts. So, if we're looking at something like a building, then our brain dissects it into features such as its doors, windows, and so on, and analyzes whether it is a familiar building or not based on those features. Our second object recognition mechanism involves a holistic-based strategy. This approach involves perceiving objects as an undissected whole, where our brains are explicitly not breaking the object down into its component features. So, when we look at objects, we can use both these strategies, but the proportion of each that we use depends on the type of object. For most everyday objects, such as houses, aeroplanes, printed words, and so on, we rely much more on our feature-based recognition system. Martha Farrer argues, on the back of a considerable amount of research, that certain overlearned objects, like faces, are recognized almost entirely by our holistic system and only a tiny bit by our feature dissection system. That means that when we look at a face, our brains are not attempting to dissect it into its component features. And what Farrar argues is that this is the key difference that means that we find faces harder to differentiate when they're inverted. The idea is that when we use feature analysis to recognize something, then this strategy isn't impeded very much when the object is turned upside down. However, when we use holistic information to recognize something, then this strategy is far more affected by being turned upside down, because its holistic information is proportionally much more impaired by inversion. And this is exactly what Martha Farrad's experiments appear to demonstrate. What does this mean for PhotoFits? Well, traditional PhotoFit systems are very much focused on getting people to analyze faces feature by feature. That is, the eyewitness sits down with a big library of different features to build up a picture of the person they saw. You choose a nose that fits, then you choose a mouth that fits, and so on. Here's an example of a PhotoFit created in research on the topic. Can you guess who it is? Most people would struggle to recognize it's David Beckham, the footballer. Even when the target face can be directly viewed when the PhotoFits are created, we tend to get poor likenesses. Of course, in a real crime, it's likely to be even worse because the witness will be doing it from memory, possibly a flaky memory. Why does this approach seem to work so poorly? Maybe it's because it assumes that witnesses recognize people feature by feature, when the research indicates that's exactly what they don't do. That is, when you see someone in the street, you don't look at their nose and then their eyes and then their mouth to see if it's someone you know. You look at the whole face at once. That is, traditional PhotoFits fail because, as revealed by psychological research, they make a fundamentally wrong assumption about how people recognize faces.